like a laser pointer in a plane.
No, it's really useful.
Okay, good.
Now, I guess I have to ask again, are you seeing my screen? Well, people are still coming in.
You'll have to, so now you'll have to go back and reshare your screen since we're in the breakout room.
Ah,
So
kind of like that.
kind of like that. That's perfect.
I'm always surprised when it works. You know, I've
Yes,
done it, what, dozens? I don't know that I've done it 100 times, maybe, but I'm still always surprised when it works.
yeah, me too.
But it does.
It does.
You guys are welcome to unmute and ask questions. I will tell you, I'll be thoroughly honest. It's not like I ran the trip and took all the pictures that I wanted and have a perfect presentation. I was delighted in that I dug through my computer going back, almost 2 decades of running trips along this stretch of Lake Superior. And you'll see that it's pretty spectacular geology. And it's close by, so keep that in mind. So I think I have enough pictures that you'll get a good idea of the logistics and what the area has to offer. I will also say maybe this picture reminds me that you can think about the university academic semester, and we're wrapping up in April, and I was slowly getting pushed to the point that I would run the trip after the semester, and the students were kind enough to come along with me. I've been thinking and working and moving towards this standard. Essentially what I want to do is look at the geologic history of North America and how the continental part of the plate was assembled. So I'm moving towards that in a variety of different ways, and this is one way that helps me. So just seeing some of the materials there will be useful as far as moving towards this, plus the opportunity to collect samples that I can connect to geologic maps. Key things here in this NGSS standard: age and locations of continental rocks, finding some radiometric ages that the students could calculate for different parts of North America. The pattern that the oldest continental rocks are located at the center of the continents. So finding the right dated samples, which I think would be relatively easy to do once we get going on it. And that the ages decrease from the centers to the margins. Let's see, and what's the bottom one there? The regions farthest from plate boundaries, continental centers, will have the oldest rocks because new crust is added to the edges of continents. So those are some of the big ideas that we can move towards. So this might have been one of the last times or most recent times I ran the trip. And so I'm running with university students, but your students might be different, or you might want to go on your own. But of course you need a passport and an enhanced driver's license. So you can see I run the trip in late September. So usually I'm emailing my students in July or August saying, if you're going to go on this trip, check your license. It's a good idea to get an enhanced license. So take care of it. And the students do, which is great. That gets done. In the old days, I tried to make the trip as efficient as I could. And that meant the students could go to classes on Friday, and we'd leave Friday afternoon and essentially drive that 5 or 6 hours to get to Sault Ste. Marie. I would put them in their hotel rooms, and we'd get up and do a lot of geology the next day. So Saturday they have breakfast. We were crossing the border at 8. We spend the good part of the day doing the geology. And then we drive home and get home usually at about 11 or midnight on Saturday night. So it's a fairly compressed, quick trip. Constantly on my mind is the timing and moving things along. I guess I'll say no dilly-dallying, because I realize any extra half an hour I add during the day gets me home at 11, 12, or 1 in the morning, something like that. So basic clothes they need, some gear, mostly living on fast food, that kind of stuff on this short trip. Down there it says we stayed at the Mid-City Motel. I'll just tell you, don't do that again. It's been there a long time. I guess I went there for 20 or 30 years, and it's time to go somewhere else. So we'll just leave it at that. If you know the Mid-City, okay. There's some good safety things to go on here. One is that typically I might have a student driver in my second vehicle, which can terrify me. They range in their skill set. So we usually don't break any speed records. We stay pretty close to the speed limit because we're in 12-passenger vans. More and more, depending on my trips, I encourage the students, if they have a pre-existing condition I need to know about, like a recent trip, I had a student carrying an EpiPen. She carried one, I carried one. We were both aware of it, but those kinds of things are important. Students are going to climb all over stuff. At one point, we're on a bridge over a river, which would certainly be fatal if you fell. You're near water, whether it's the lakeshore or some of the rivers. We're near the roadway. So just constantly watching and being careful, which we're all used to, but typically our students are not. Safety glasses, these are really hard rocks. And so as you smash them with your hammer, they smash you in the face. So keep that little bit in mind. So we crossed Sault Ste. Marie. I have more stops than this, but in practical sense, you couldn't squeeze too many more on. So this is the road, of course, going up to Wawa, but this is a really good full day. Students really enjoy this. I mean, I have students that I've done this with general education students, and I'd have to check, maybe a couple of flip to geology, but it's something they really enjoy in their undergraduate education. So if we get all the way to the end of the road, or at least the end of this set of field stops, it's 83 miles down the road. So even when we finish at 3 or 4 o'clock, we've got an hour and a half to get just back to Sault Ste. Marie. So the logistics are always running on my mind. One disappointing thing is there is a newer guidebook to this area that I can't find my copy to. So although I looked in lots of good places, maybe someone borrowed it and I didn't get it back. But Dr. Pai wrote a good field guidebook. So a lot of these were picked. There are probably newer guidebooks as well. There are geologic maps. As you might guess, a lot of the pink area there in Canada is metamorphic rocks with some igneous intrusions. All those red lines are mafic dikes cutting across the area. The yellow at Mammoth's Point are Cuban almond lava flows that you guys are already familiar with. So there's a lot there. I usually don't use the geologic maps. The students I take are essentially intro geology students. That would be a good way to think about it. Way back when I was oh boy, I have to calculate, a beginning PhD student. So in 86 and 87, or maybe around that time, we traveled from Northern Illinois University by Chicago and came over to the Mammoth's Point area, and we collected basalt samples from a section of rocks. There's a big stack of lava flows there. And then we went back and we did various chemistry things and used them for class projects. So surprisingly, as I compiled this, I've been going here over 30 years. So it's a place I'm familiar with. So a set of stops, a set of teaching objectives, I guess, with my students. So commonly thinking about texture and composition as they approach the outcrop. Can they see things that we as geologists want them to see? And then to step back, can they make a sketch and show me their interpretation of what the geology is? And of course, the scale would be useful, and some compass bearings, that would be a good thing to add. And then just describe to get them to look a little closer, even on the top part of the outcrop. So you guys will probably be happy, fair number of pictures in here. I don't like these Canadian vandals that like to put stuff on their rocks. But this is our first field stop, fairly busy road because we're still not far from Sault Ste. Marie. The students are pretty good at investigating and figuring out what we have here. It is essentially a granitic gneiss cut by a diabase dike, and they can work those kinds of, they can identify those rocks and those field relationships. The gneisses are absolutely beautiful. They're great for the students to make that jump from a box of rocks on the table to what they actually see in the field. And then the other aspect, of course, is nearly all of these outcrops are glacially polished, so that gives them an opportunity to make a connection to the landscape. So again, just some photographs of gneisses, and they're good outcrops in places. The granitic aspect to it might show a little bit more, and that's good for the students to see that there's essentially a continuum in textures and compositions. There's my quick little sketch of what I would expect the students to take away. I don't have a scale in there. I think the dike is about 20 meters in width. So we continue on up the road, same kind of questions. What are we looking at here? Why is it red in color? Have these rocks been deformed? And then suggest some observations. You guys might recognize this rock. Anybody want to guess? It's a rock you know.
That Jacobsville sandstone?
That's what I was going to say.
Yes, there you go. Thank you very much. So this is Jacobsville. It is tilted up on its side. Robert over there on the left-hand side, you can see that he's taking a picture, but we can also take a Brunton compass. So this Jacobsville, you can still see the bedding in it. It's been tilted and deformed by a nearby fault. Of course, this is associated with the Keweenaw Rift. So here the students can see that sedimentary structures or sedimentary layering can get deformed. They're seeing a sedimentary rock. So this trip is great because it has a good mixture of sedimentary, metamorphic, and igneous rocks. And so here's a chance for them to see a sandstone. The cement has got an oxide in it, so it has a reddish color, those kinds of things going on. So Chippewa Falls, I don't know how many of you have been to Chippewa Falls. It's a fantastically beautiful place. There's often fishermen there. Typically I go in September, October, the trees are changing colors. I've seen bald eagles. It's just a great place to go. It's a fun trip. There's an upper and a lower falls, and we reach the lower falls first. So there's light and dark colored rocks. Can you tell me something about the dark colored rocks? Is there something about resistance to erosion here that we might be able to interpret? And again, draw a cross section. Making them draw is a good way to face what they know and don't know. There's potholes here, essentially drilled into the rock in the bottom of the river. Depending on the stage of the river, sometimes you can see them. They're on the far side. I'll explain that a little bit. So some years we see them, some years the river's a little bit too high. When the river gets high, this can be a dangerous place. So this is just a picture I pulled offline because all of my pictures like this have students in the foreground. And so here's the river, here's the falls. You can see an area with dark rock. Near the base of the falls, you see a lot of pink rock again. There's another area of dark rock up on the top. Typically we can get here and move around. And so with a little bit of helping each other, we can get across these little bits of the river, jump across the channel and catch each other essentially. The students like to climb around. You know, typically we'll get there and we'll look around for a while and then we'll come together and start making interpretations. There's the potholes are over here on the far side to the left of the photograph. So it's something you have to essentially cross over and go look at. upper part, this would be the upper part of the falls up at the top of the waterfall. So a couple different things that you'll see is that here's a nice granitic rock at the base, the student's standing on it. There's a contact. I don't have a good picture of the contact, but you can see that this dark colored material essentially flowed into nooks and crannies and cracks and filled those as it was moving. If you're careful and you adjust your eyes, for example, up on the top left, you can see that there's curved features inside the dark colored rock. You guys would recognize those as pillow lavas. So these are black lavas. These are Keweenawan lavas sitting on top of a granite. The granite, I think, is about 2.7 billion years old. The basalt on top is roughly 1.1. So the gap in time here is really significant. 1.6 billion years of time to essentially bring that granite up to the surface and have nothing preserved on top of it. So the students get a good job, you know, essentially identifying the granite, identifying the basalt, looking for structures inside the basalt. This is up at the upper part of the falls. The feature there is interpreted to be a dike. So up on top, at the lower falls, the feature is a lava flow on top of the granite. At the upper falls, it's a basaltic or diabase dike cutting across the granite that's there. The students do okay. There's another place just to the right of this picture where you can see the contact of the diabase dike and the granite. So usually I'll stand over there and get the students to get moving on the right direction for their interpretations. The other thing in this picture, you see that the rocks are pretty lichen covered. So sometimes you have to look around to find a good exposure where they can actually see the composition of the rocks. You guys can unmute and chime in whenever you want. So there's the upper falls. It's black, it's fine grained, it is a basalt, and there's the simple cross section. And it's some good two-dimensional thinking for the students to get there on their own. Lots of good students. One carry away from this is what, I don't know, is there 13 students there? 5, 6, 7, 8, 9, 10, about 13. These are almost all earth science teachers from Bullfrog, Arizona now, to Tooele, Utah, Mason, Michigan. I'm not sure where Robert is, he moves around. Christy runs Forest Hill Central Science. I talked to Molly on Tuesday night. She's in Louisville, Kentucky. Andrew's a geologist. Brad is now at Zeeland East and doing a great job. Adam's in Texas. And our chap over here is over at West Ottawa. So a great group of students this year. So this is part of the reason I have lots of pictures. But the other is now Grand Valley has 5 earth science teachers. So our numbers are really down. There is a place to stop. You've probably been to the Agawa store, so you can always get you a quick lunch there. It's the bathroom break on the trip, so that helps a little bit. Even on the way back, we stop there sometimes just to run through the bathrooms if somebody's asking for it. There are pit toilets in places once we get up in the provincial park, and that helps too. I do have a couple beach stops. I don't necessarily stop very often because these students go to Lake Michigan beaches and these are not dramatically different. But if you wanted to have a beach stop on your field trip, there's good opportunities to do that. And the provincial parks are fantastic. I'm thinking about some other Canadian trips where we might do group camping to keep our costs down. So way back when we went to Mammoth's Point, we were going there for basalts, but it also has copper. So the Native American presence has been there quite a long time. The area had active mines in the 50s and 60s, but there's nothing active anymore. You'll see the two rock types that are here. They're impressive and beautiful. Where you can look at contacts between different kinds of geologic units. You can think about their orientation in three-dimensional space. So there's some good field skills being developed here. Okay, I've talked too long. What do you guys see?
Is it a basaltic lava flow?
Very good, thank you.
Conglomerate underneath.
Yeah.
There you go. And so in the foreground, you can see those large clasts. The clasts tend to be granitic, but some of them can also be basaltic at times. The lava flow came right down on top of it. There's no evidence of much of a gap in time or erosional contact between these two units. The lava flows have varying thickness. The one that comes to mind for me would be maybe 7 to 10 meters and tilted. This one's pretty skinny. There are vesicles that are filled with calcite typically. It's easy to find flow tops here. Of course, this one's really easy to get the flow top. But even in the thick Pahoehoe flows, they're inflated Pahoehoe flows. You can use vesicles. You can see the crust at the top, dense core of the flow at the bottom part. So beautiful conglomerates here. I'm not sure what Andrew's trying to chip out of the rock unless it's a class. It's a little bit hard to take a good sample home because it tends to fall apart. But every once in a while, you'll find something along the edge of the road cut that you can carry home and have a really nice conglomerate in the classroom. The students on the left are, pardon?
Those are some big clasts.
Yeah, it's really impressive. I was reading about diamonds in those rocks. I didn't know there were prospectors looking for diamonds inside that alluvial conglomerate. So lots of lavas. It's easy to go there and collect essentially all the basalt that you need to, and maybe a little bit of conglomerate. It was interesting that, Sherry, I think you were talking about sending out rock kits to your students, and I did that for my college students, but I think my stores are depleted. So if I have to build another round of rock kits, I might have to go on the road for a while and fill up crates.
Might have to hook you up.
Yeah, it's some stuff's easy to get and some stuff is hard. So a little bit, the reason we went there to collect lavas is there's stacks of Keweenawen lavas there, just like you guys are used to in Houghton. This is over on the other side of the lake, but they're the same age and same characteristics. They're beautifully exposed. It's essentially a stack that's been tilted towards the axis of the rift zone. And of course, then the road cuts through it. So we have a stack of nearly 5 kilometers of basaltic lava flows that we sampled to look at chemical changes over time. So nice group of students, they're pointing up to the top. And what I wanted to show you is if up on the outcrop about 2/3 of the way up, you can see ropey surfaces of Pahoehoe lava. This is on a flow top that is 1.1 billion years old. So this is pretty amazing preservation. I don't know why the glacier didn't scrape it off. Thank goodness it didn't. Finding this stop, you can see we parked beyond it. Notice the Highway 17 sign or whatever that is. I think that's my road marker. I drive down the road watching my odometer and looking for that 17 sign, and then we come back to look at the ropey surface of the basaltic lava flow. That outcrop, it's in the shadow. I don't have a picture of it looking sideways, but that's the flow top. And you can also go find the flow bottom where it's resting on the next Pahoehoe lava flow. So that's a good thing to get the students to think about as far as skills and estimating volumes of lava flows. Some things I'd like to do in this area that typically, you know, if I have 20 students with me or something, I have to pay attention. But there are places where, for example, where you see the hammer on the left-hand side picture, that lava was flowing across that granite and essentially ripping up or tearing up clasts of granite. You can see that it's pretty blocky, and just incorporating that into the lava flow. So I've always thought about, could I come up with a good mapping exercise for the students so they could see how dynamic these flows were when they're moving. We did sampling way back on that student project in grad school where we were moving along the coastline, and there's some interesting rocks and textures. Of course, it's difficult to hike right along the coast. It's quite rugged and probably dangerous. I wouldn't want to do it with students, but it would be nice to go back and spend more time where we could look for some key outcrops that we'd like to take students directly to, something that we could do safely. Here's Ken's study. So essentially we got them started and they realized they had a good project to work on. I think Ken did this either as his PhD or his postdoc at Northern Illinois. He found 5 different units or something like that he could use and look at the different kinds of geochemistry of these basalts. So you're looking at changes in the mantle source region over time as these lava flows were stacking up in the mid-continent rift. One thing that I don't have a good picture of that's always kind of interesting is the students get to go down to the lake. I'll show you some pictures. This is a great place to pick up all kinds of beautiful cobbles. But as we come down the highway, we pass an area where you see concentrations of cobbles that look just like the modern day beach. And so these are essentially ancient, older cobble beaches that are now based on isostatic rebound. They're getting lifted up above the modern day lake shore. So it's a good feature to show the students to get them to think about, how does this happen? How do you get the old lake shore up higher? It could be a change in lake level, but it has to do with isostatic rebound. I love this place, but it's absolutely scary. I asked the students to draw a cross section again, do something about scale. Can they put a north-south on it? What structures are there? Is it a dike, a litholith, a sill? So I give them a pretty good hint. What's older, the lighter dark colored rock? What do they think it is? Typically, I think I have an aerial view coming up. We park down the road and walk back, but we're standing on a bridge to see this. I'll point out the safety issues. The fall, of course, would kill you. We often park off to the left and approach where you see the fence. And the students listen, which is great, but it's dangerous. You don't want to get too close to the edge because the fall would be tremendously dangerous. So one thing you see is the beautiful dark water, but if you look up the river just a little bit, you do see a dark colored feature that's cutting across everything. It seems to be inclined, and it's essentially at the same inclination as this area that's been eroded away. So a good example of the hardness of the granitic rocks and the softer, relatively softer basalt that's there. I didn't know whether I'd find a picture from the bridge. So there you see the bridge in the bottom of the Google image. We usually park down to the left where we can get off the highway and then walk back. But to see this well, we usually walk out on the bridge, big trucks going by. We try to time it so we're not out there when vehicles are closed. So sometimes I'll take maybe 5 students at a time. This is a hydropower plant. I would love to go climb around the river, and looking closely at this image, which I'd never done before. If you look at the top of the image, you can see how straight the river channel is because it's exploiting the pre-existing dike. But sort of top and center, you can see where the basalt is actually up at the surface. And so that's kind of interesting. I'd love to go up there. Maybe if I ask real nice, they'd let us drive up there and look around. So spillway for a little lake up there that they use for the hydro electric power. Interesting spot. There's the simple cross section that I asked them to draw. And there's a zoom in of a Google image where you can actually see the basalt dike at the surface close to where the granite is. I didn't take a picture. There's a rock in my yard that's just amazing from up here. There was a sample I looked for that I loved with a biotite schist intruded by a granite that I had around our labs for quite a long time, and now it's disappeared. I don't know who's got it. But it was great because I could get the students to essentially recognize, oh, that's a biotite schist. Well, what's the other one? Oh, that's looks like a granite. Okay, how does granite form? So just in my hand sample, I could ask them which is younger, which is older, how would you know? And in the field, there's just so many basalt dikes that, you know, after an hour of driving down the road, it's like the students are like, yeah, I understand basalt dikes now and that kind of thing. So the variety of metamorphic rocks is fantastic. And there's a good variety of intrusive igneous rocks as well.
Hey, Steve.
Yeah.
You know, I know you're probably thinking, here it is, you guys go explore. But could you ever be talked into doing this trip for Mesta?
Yeah, probably. It'd be a lot of fun. And
yeah, it would be.
Yeah.
The tricky part would be my schedule. So when to
Sure.
do it, you know.
Well,
Currently I'll be coming back. If I get to go to Iceland next summer, I come back like July 30th or August 4th or 5th. So it all depends on when it would happen. But we'll do Dave's trip and then we'll go beyond that.
okay. All right. Let's put the little bug in your ear. We're
Yes,
at your
thank
university,
you.
man.
Do you have a trailer to put rocks in?
I have a Ford F-150 and I could hook a trailer up to it.
There you go. With the students, I don't go to Agawa Rock, but I have with my family. It's a beautiful, interesting place. Adults would have no problem hiking down there. You do stand on this sloping surface, which can be wet, so that part's a little tricky, but it's quite a beautiful, interesting place. Just collecting cobbles. You could build a rock collection just collecting cobbles that are coming out of these fantastic rocks. So again, metamorphic igneous, not many sedimentary. Sand River, let me think for a minute. Sand River is almost always about as far as we go, but there's some really neat things here that you can tease out of the students and make them realize they can do more than they thought. So this is looking up Sand River. It's beautiful. Again, the students, it's a great photo op. They like having their pictures taken. That kind of thing, that's all fine. Just looking, I asked this in class the other day, can they see, how many rock types do they see here? And I have them boat on their shoulder, that kind of thing. But there's obviously a gneissic, dark colored rock here, and it's being intruded by an igneous rock. There's a little bit of igneous rock plastered on right there. So right off the bat, they can quickly say, oh, this area used to be metamorphic rocks. I see that it's being intruded by a granite. That part works pretty well. So this is, I just wanted you to see the picture on the right-hand side. You can see the light colored granite. You can also see the gneissic texture. But the other thing is if we walk up the river a little bit, you can see dikes, mafic dikes cutting across the granite. So now your story is a little more, I won't say complicated, but maybe complete is the right word. So now the youngest rock, what you thought the intrusive igneous rock was youngest, it's getting intruded by even one more different kind of rock type. And if you think about sort of the geologic map that you saw way early on, large areas of metamorphic and igneous rocks with these basalt dikes cutting through. So in this case, the basalt dike is 8 or 9 inches, not very big, but it's a nice way of on this river saying this is sort of the geologic history of this region. We can piece it all together. This was funny. I went to get a picture of Sand River. I have this in my mind. So we go up the river and we look at those rocks that I just showed you. And then we walk down to the river mouth. So the picture of Google Earth is a nice February or something like that. So the lake is here. It's just frozen over and covered with snow. But this is a nice area because the river comes out. There are dunes in the back area. There's an active beach, those kinds of things. And so getting the students to scoop up sand and look at sorting and grain size, those kinds of things of a few different environments that are in real close proximity to each other is just a way to bring in something about sedimentary rocks at this location. So let's see, usually at that point, they're getting tired. They're college kids, they're tired all the time. I'm calculating in my head, you know, do I want to go to stop 7? I don't know that Catherine Cove adds that much to the trip. I'm going, oh, it's 17 miles up there, then we're going to be there half an hour, 17 miles back. You know, that adds an hour to me, to my trip, and they get home an hour later, that kind of thing. So pretty much I'll get to the Montreal River or Sand River and then turn around and head back. The students do what students do. Well, I got one picture of Catherine Cove. So again, metamorphic and igneous rocks. These are really beautiful outcrops. You guys would really enjoy them, polished by glaciers, but not anything new. So that's, you know, when you guys run trips, you have to decide how many stops. This is what the students do on the way back. You know, I'll be driving along. I look in my mirror and it's like 9 out of 10 students are asleep. Andrew's a great kid from Hudsonville who's now a geologist and having a nice career. But those were in the van, believe it or not, and now he transferred them over to his truck. So excellent. Beautiful specimens.
Excellent, yeah.
The other is that, you know, when you think of going the other way to Marquette or the Keweenaw, those are extra hours. You know, I would probably have to add an extra day to the trip if I wanted to go all the way to the Keweenaw and see as much. So yeah. I really like the trip in the variety of materials that it offers in a short stretch of road, really. Yeah. So that's part of the reason I haven't gone in a few years because primarily our class sizes have shrunk. So I used to run this trip on like one Saturday, and then maybe 2 weeks later, I'd run a trip to Marquette. And I would tell the students, you got to pick one. You know, if you want to go to Canada, you know, get your enhanced driver's license. If not, we'll take you to Marquette. We'll have a great time there. So that part, I have no idea if Canada would let us in right now, but hopefully in a year or two, it would be pretty easy to do. Never had problems bringing rocks back. You know, they don't really care. You know, you tell them you're a school teacher and everything's fine.
Yeah.
That's what I have.
The answer on Canada is no, they will not let you in right now.
That's true.
Good for them.
Until October 21st, last I checked.
Yeah,
wow.
But I expect that will be extended.
Well,
there.
Steve, seriously, I mean, this, I know you're a busy guy, and you're busy next year with Iceland. I hope you are.
Yeah.
We are planning in the summer of 2022.
Yeah.
Peter looking at running a trip kind of around the St. Ignace area.
Mhm.
And my mind right now is just turning its wheels. And I don't know if you would be interested, and we could do both in the same trip kind of thing. Do Peter's part, do your part, but don't need an answer now. I just want to put the bug in your ear.
Yeah.
Get you thinking about it. If summer 2022, you think you might have 2 or 3 days to spare to take us slackies up there, I'll tell you what, I'll buy the drinks for the time.
Okay, that might be a good deal.
The camping at Pancake Bay or Batchewana Bay is really, really nice. The parks have really good facilities. You know, so it'd be easy enough for us to get up pretty far and then, you know, maybe stay 2 nights in one place or something like that, to come back. And no, I'm pretty happy to do it. Let me think for a minute. Yeah, just ask me a year ahead and I'll probably make a commitment.
And I'd be happy to be your slacky and make arrangements, you know, do all the grunt work, you know, kind of stuff. But yeah, and I don't, you say you do this in September. I mean, to you, does it matter doing it during the summer? Or I would think you'd be less busy in the summer. I don't know though.
Yeah, I don't know about the Canadians using the parks and that kind of stuff. So
yeah, okay.
But the parks are pretty big. I don't think it'd be a problem to get, you know, 5 or whatever campsites, whatever we need. In fact, I kind of want to explore the group campsites because if I understood it correctly, the prices were really cheap and really, you know, you just have to walk a little farther to get to the bathroom or something like that.
Yeah.
And so
It's
gently
less
twist
buggy,
my arm.
less buggy at the end of the summer.
I'll twist your, yeah, Peter,
Or
are you here?
twisting. That would be fun.
Peter, are you here? Peter? Nope, guess not.
I guess not.
I was just gonna
I don't
have
see
him
my
chime
list.
in about his part of what I'm talking about. Anyways, all right. Well, thank you. I'll twist your arm.
Yeah, that would be fun.
Sooner or later, I'll find my guidebook. And it was funny that I even went online trying to find one to buy and I couldn't find one. So I don't know where it got to. It'll come back to the top sooner or later. It's a well-designed guidebook.
Well, is it called the North Superior North Shore by Thomas F. Waters?
Does it have a spiral binding?
You know, I found online eBay. I found the old one you showed.
Yeah.
In doing this, I found one. I can't tell if it's spiral bound, but it has a cliff, and then the water. It has a really, you know, vertical cliff. Blue sky, vertical cliff, a rock on the left, water on the right. And it's Superior North Shore, A Natural History of Lake Superior North Shore Lands and Waters by Thomas F. Waters.
I don't know.
Yeah.
Anyway, we'll find it. I would benefit. We would all benefit from getting some more recent literature. And there's a group, do you guys know about the Institute of Lake Superior Geology?
No.
No, I never heard of it.
So they run trips in May.
Okay.
And they do go around Lake Superior. They're a really great group. They usually have like a 3 or 4 day meeting. So they'll have a sort of sessions and things inside and then a field trip day in the middle and maybe field trips bracketing the indoor sessions. All kinds of people, prospectors, a lot of students and grad students. I've been twice. It's always really useful trip. So they probably have something along this section that we could find to get more recent interpretation of the rocks. That's what I'd like to have. Well, good to see you guys.
Oh, great to see everybody, and thank you. This is cool. Really,
it's great to see you guys too. I mean, Steve, this is great to see you. I mean, you know you're still out there.
Yeah, I'm still ticking. I'm all right.
That's good. Just making sure. How's
Oh, yeah.
Tari doing?
You got me excited. I want to go check this stuff out, man. And I want your wisdom and knowledge to be with me, man.
Well, there's a lot there.
Yeah.
The other place that I went with the student as far as working on this assembly in North America is the Grenville front. On the way to Sudbury. Have you guys been there?
No.
Biotite gneisses with big garnets in it. The garnets are like the size of your fingertip, you know, maybe a centimeter in diameter or something like that. But the part of it is that the contact, the suture between those microplates are so dramatic that, you know, it should smack the students, you know, to realize that, oh, I was on that part of North America and I crossed this fairly narrow boundary and now the rocks are totally different.
Yeah.
And still metamorphic, but totally different from what's in Andrew's truck right there. So that's kind of a long-term goal, is to keep working on that.
Well, you know, we don't have to make this a real short trip, but, you know, we can make a couple days and check that out, man.
You're going to fill your
Longer.
truck by the time you get to stop 7. So
Yeah.
Okay. That's why I bought it, to fill it. I'm
Oh,
telling you.
Kevin,
Yes.
for what it's worth, I always thought suggesting a trip to the Sudbury area would be an interesting one too.
Well, there we go.
yeah.
I'd be very
Yeah.
interested in that.
Me too. Me too.
All right,
Definitely.
Steve. Steve's a
Definitely,
place to come,
yes.
man. We need you.
In researching the trip for the other end of the UP, I discovered that the what is it, the ejecta from the Sudbury impact all across UP, Wisconsin, Michigan, played a really critical role in helping to age date a lot of the different strata and be able to relate them across those areas. So it had a lot of important significance.
Cool. Cool. Yeah. Excellent. Well, Steve, you might have created a beast you didn't want to create, but presenting something like this to us, you had to know this was coming, man. We need you. We want you.
Yeah, for sure. That's for sure. Absolutely. This would be a phenomenal trip.
Summer 2022, man. Knock off some time now.
We'll see how it goes.
All right. So how hopeful are you that Iceland will happen this summer? I mean, 2020.
I almost have all the students I need. In fact, I'm sure if I think I'm at 12 and I take 16, they'd probably let me run it at 12.
Well, do you think things are going to be okay to go? I mean, it's hard to tell.
Yeah, it's hard to tell.
Yeah.
And Iceland's fantastic about protecting their population.
Right.
They just arrested 3 Frenchmen who broke their quarantine, went to a bar, and infected 100 people.
Oh my
so
God.
I don't know what they'll charge them with. Public nuisance for sure.
Yeah.
Wow.
But
Yeah.
typically now when you land, you need to do a test. And if you don't pass your test, you go into quarantine for 2 weeks. So
Yeah.
taking students in that situation where all of a sudden we'd be split into different groups and some kid who dished out $3,000 is not going to get what they paid for, blah, blah, blah.
Yeah.
But I won't make that call. They'll make that call in March or something and decide
Yeah.
whether we're going to go in July.
Well, I hope you get to. I hope you
Yeah,
get
I
to.
hope you do
Yeah.
too. That would
Actually,
be
yeah. I'd love to join you. Another curiosity question. So coming back into the United States from these trips, how many students have you left in Canada at the border?
I guess we have time to tell you interesting story. One time we went across and we got tagged to go in and they asked us questions and the guy handed back all our IDs or whatever. And I think it was driver license, but it was after 9/11. And they said, everybody's welcome into Canada except that guy right there. You're going to have to take him back to the United States. And I'm like,
Wow.
okay. And he said, you know, turn around there, go through there. So you go across the bridge and when you get back into America, they've got you tagged and they're like, you were denied entry into Canada. And there was this big kind of shed with just aluminum siding on it. And they said, roll down there and the garage door will open. And so when the garage door opens, there's like 6 guys at least, and they all have automatic weapons across them.
Oh my
So I don't know if they're
God.
border agents or whatever. But the guy essentially, said, please exit the vehicle. So we all get out. And they had a little guy. The little guy crawled through the van underneath the seats, looking around. And, I'm pretty jovial and chatting with them. And I don't know that I ratted out on the kid there, but so essentially they looked and they said, yeah, you guys are good. And we left. But the student, his infraction was at Grand Valley, his roommate's girlfriend was locked out. So she was trying to like jimmy the window to get into the apartment. Grand Valley police see that she needs help and they go to help her. And as they get open up the apartment, they see stolen property in the form of construction cones. So this kid had, for whatever reason, took construction cones. They were in this apartment, seen by the police.
Oh,
And the kid's got a criminal record on it.
Oh
And
my
that's why we were
God.
denied entry into Canada. It's just like,
so what did you do? Did you leave him there at the border and continue on with the trip?
that's what I said I was going to do. And I had a student start crying about leaving someone behind.
Aw.
And I'm like, oh, come on. So we went to Grand Sable Dunes. We went to Tequamanon Falls, so even I had a plan B, and I always take a plan B because you just don't know whether the border is going to work or not.
Yeah. Yeah.
So were all the other students okay with not going on the plan A? And
Yeah, they were okay, but they got shortchanged in my opinion.
yeah.
Yeah.
I don't think that kid's a teacher either. So
Oh my gosh.
Wow.
That's no, it's good to hear those kind of stories.
yeah, it's crazy.
For those of us who do field trips and how you handle it. Wow.
Yeah.
Yeah. And
I-
how would you ever know?
I would have been inclined to leave him there and say, get a taxi. But
I was going to make them, my torture was to put them in the library at Lake Superior State for about 8 hours. That could have killed them.
That would do it.
yeah,
Wow.
pick you up on the way back.
There
Oh
you
my
go.
gosh, Steve. You must have been crushed. Oh, I would have been upset with that young
I
man.
just shake my head. It's kind
Yeah.
of like,
You learn to roll with those things.
there you go.
Wow.
Well, thanks for sharing that. Very good.
Yeah.
Thanks
that
for the
was great.
presentation.
I-
Wonderful.
That would be really fun to do.
Yeah. No, you got me geeked, man.
Well, if you guys go before, I have some pretty detailed highway maps that help me locate things. And it'll say like, okay, from the last stop, drive 11 miles, so
Yeah.
I'm
Okay.
sitting there usually navigating before I head out for the next stop because it's usually just me. I don't have another professor with me.
Okay.
So,
Well, like I said, I'd be happy to be your slacky, your driver.
all right, there you go. But we'll see.
Well, Steve, for the future, Indian Trails has a bus route from St. Ignace all the way to Grand Rapids through Traverse City.
Oh, wow.
We've had to use that a couple times when the car quit or she got injured, so on a trip. So had to put her on her bus after she broke her shoulder.
Oh, ouch. Well, it's good to know. Thank you.
They do go all the way across to the UP too, so you can actually pick it up in Baraga
Wow.
and Marquette. So
Wow.
Well, thank you guys for attending. I'll see you later on.
Oh, you
Yeah.
bet.